The last class we were discussing basically how to do paper 5. So it's ATP paper, and we did till we were doing a question in which we were finding out the gradient of a given data. Okay, and also we were doing how to how to draw the best fit line. How to draw the best fit line. Okay, and this is how can we find a gradient of any line. Okay, let's suppose this is the straight line that is obtained after having any particular data. So first of all, you have to make a triangle. Now the question is like how much I should draw the triangle. Like I mean to say, okay, what should be the size of this triangle? So remember the 70% of the line should be covered. To get the best results, 70% of the whole line is covered. It's not just like कि आप इतना सा draw कर दो. No, you would not be getting any, you can say, better results if you are drawing only this much triangle. It's a very small triangle, okay? Whenever you're going to find gradient of this best fit line, straight line, so you can make a triangle which should cover 70% of the line, okay? I'm not saying that you are supposed to make the whole triangle in which it is covering 100% line. No, it should cover 70% of the line. Okay. Then we would be applying the formula that is y over x. Or if I have the curve, if I have a curve, so how can we find out the gradient? So you can do this. First of all, you have to draw the tangent. Tangent, what is tangent? Basically, tangent is a line which touches any one point of the curve. As you can see, this yellow line is the tangent line, which is you can say touches one point of this curve. That is this. So I need to find out the gradient. So of course, this is the formula that is y over x. Y is 2.5 and x is 4. So I would be dividing these two values and I would be getting the gradient. In this way, you can find out the gradient of a straight line, and also you can find out the gradient of a curve. So you will see the two types of questions. Sometime examiner would be giving you the data and would be asking to draw the graph. So you would be getting a straight line, and in some cases you would be getting like the curve. Okay. After this, we have to do error analysis. In a single paper, for sure, you will see this question. It's related to error basically. You know, in the lab, when we are going to use a burette, okay, so you will see that a burette consists of 50 centimeter cube in total. This is the burette. This is the burette basically. So the total size of a burette is 50 centimeter cube. And you will see the marking 49, 48, 47, 46, 45, 44, 43, 42, then 40, then 39, then just like that. Okay. So this is the picture of a part of burette in which you will see the graduations between 5 and 6. You can see 5.1, 5.2, 5.3, 5.4, 5.5, 5.6, 5.7, 5.8, 5.9, and this is 6. Okay. So it consists of 10 small divisions. Each line is going to show zero point 0.1. That's the reason. 5 plus 0.1 is 5.1. So this is your 5.1, then 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, and then exactly this is 6. Okay. Uh, what is uncertainty and what is the least count? Least count means that a minimum volume which can be measured from burette. That is called least count. So the minimum volume that we can obtain from the burette is zero point 0.1. So the zero point 0.1 is your least count. Zero point 0.1 is your least count. Okay. Uh, what is uncertainty? Uncertainty means that you are going to use a titration. Okay. You are going to use titration. And this is your burette. This is your burette. Okay. This is 4.1, 4.2, 4.3, 4.4, 4.5, 4.6, 4.7, 4.8, 4.9, and this is 5. And this is 5. Okay. So after doing the titration, I told you, can you tell me the reading of the burette? So let's suppose you have used the volume just like that. This is your volume. This is your volume. Okay. So I'm asking, what is the volume? What is the volume? It's in between 4.1, 2, 3, 4, 5. It's in between 4.5 and 4.6. So what should I tell you? What's the reading? It's in between 4.5 and 4.6. That is called uncertainty. That is called uncertainty. Okay. Then the uncertainty arises. Then the uncertainty arises. Okay. So what should I tell you? What should I tell you? So uncertainty in burette is equal to zero point 0.1 over 2. Like the difference between the two division is zero point 0.1. So of course, if I'm getting the reading in between this, of course, that would be 0.05. Okay, of course, it would be 0.05. So 0.05 centimeter cube is your uncertainty for the burette. Plus minus, plus minus, plus minus. Okay. Uh, then he would be asking to tell me the percentage error of the burette. Of course, then you will doing an error because you're not writing down the correct value. Okay. So the error of the burette is equal to uncertainty multiplied by the number of readings divided by the total volume used. Okay. Let's suppose this is the initial volume. This is the initial volume of the burette, that is 15.00 centimeter cube. And this is the final volume, that is 25.00 centimeter cube. And how much volume is used? That is 10.00 centimeter cube. Basically, I have subtracted 25 and then 15. Okay. I got 10.00 centimeter cube. This is the volume used during the titration. Okay. So uncertainty was 0.05. Okay. 0.05. Then multiplied by 2. Why I'm going to multiply this by 2? Because we always take the reading from the burette twice. Okay, initial and then final. Initial, then final. Of course, when you would be taking the first reading, that is called initial reading. So you would be doing an error plus minus 0.05. Like you would be, there would be uncertainty. And when you would be taking second time reading, that is called the final volume, final reading. Of course, with this reading, you would be having an uncertainty that is plus minus 0.05. So those apparatus that we use twice. So we have to multiply the uncertainty by 2 and then divide it by the total volume. In this case, that is 10. So I got an error that is 0.01%. I got an error that is 0.01%. Okay. This is called the percentage error for the burette. Okay. Then we have pipette. Pipette may we generally take one time reading. If you remember during the titration, We transfer 25 centimeter cube of an acid or a base into the conical flask or anything else. So use pipette. We use pipette. We use pipette. So we take only one time reading, not just like a burette, initial and final reading. No, we can use like we use one time. Okay. So whenever you are going to find out the error for a pipette, so you are not supposed to multiply this by two just like a burette. So that's the reason I have written only one. So the formula would remain the same. Uncertainty. Okay. Uncertainty multiplied by 1 divided by the total volume measured from the burette. Okay, that is the percentage error of the pipette. Okay, this this uncertainty would be given to you. I don't know this because when you will see the pipette, so you will not see any marking just like a burette. So how can I tell you that what should be the uncertainty in that case? Okay, like in a burette, it was easier to find if you are getting the volume that is in between 4.5 and 4.6, so that is called your uncertainty. So you are supposed to divide this by 2. Okay, so for a burette, for a pipette, this is the value that is given to you, 0.05 in this case. I'm going to multiply this by 1 because we generally take one time reading from a pipette, and this is the total volume used, that is 25. So I got the percentage error. Okay, then we have weighing balance. Weighing balance, we generally take the mass of a solid from this weighing balance. Okay, and it comes in different varieties, like you will see the weighing balance which measures up to 2 decimal places. Sometime you will see weighing balances which can measure up to 3 decimal places, which can measure up to 4 decimal places. So it depends. Okay. When the number of decimal places increases, so the accuracy increases. Okay. So, so examiner would provide you okay, which type of weighing balance they are going to have. So it can count. Okay. If the balance can measure up to 2 decimal place, then the least count would be 0.01. If the balance can measure 3 decimal places, so the least count would be 0.001. Okay. So what is uncertainty? I told you uncertainty means that least count divided by 2. If you can see this, what is uncertainty? Least count divided by 2. Least count divided by 2. So again, the same thing goes over there. Okay, least count is equal to 0.01 by 2. Okay, and if you're going to uh, deal with the balance which is going to measure up to 3 decimal places, so you can use the least count, that is 0.001, and divide it by 2 to get uncertainty. Of course, in the end we have to find out the percentage error for the weighing balance. That would be uncertainty multiplied by the number of readings. So from the weighing balance, of course, we take reading twice, initial and then final. Okay, that's why we are supposed to multiply this by 2, divided by the total mass in grams. In this way, you can find out the percentage error of a weighing balance. Okay, then we have a thermometer. Thermometer, the least count is zero point 0.1. Like the minimum temperature that the thermometer can measure is zero point 0.1. That is called least count. Of course, we have to find out the uncertainty of a thermometer, that should be zero point 0.1 by 2. Okay, that is 0.05. And then percentage error would be equal to 0.05 into 2 divided by the total temperature. Again, I'm going to multiply this by 5, multiply by 2, because we measure first the initial temperature and then the final temperature. Okay, so we have to multiply this by the total temperature. After calculating this, we would be getting the percentage error of a thermometer. Okay. Then after doing this, what are significant figures? The examiner would be quite interested in finding out the significant figures in your answer. Okay, it will affect your overall answer. So when we would be doing some paper 5 questions, so I will tell you okay, how to apply this concept in that paper. Okay, we would be starting from 2024 March paper, that is the recent paper. Okay. uh loading zeros are significant. Okay, and in between zeros are also significant. Non-zero digit koi sa bhi ho, that is significant, and trailing zeros are significant. Trailing zeros are significant. That's the concept. That's the concept. Let's suppose I'm saying that you have 0.002. So you have four significant figures. If you have 508, you have three significant figures. If you have 830, three significant figures. Okay. This is the significant figures. What is rounding off data? Rounding off, sometime examiner would be asking to calculate the value for, let's suppose, electrode potential, and then and he is not mentioning that uh, in how many significant figures we have to find out the answer. Of course, of course. So I want to round off my data. Sometime we find answer in three digits. Sometime we find answer in two digits. Sometime in four digits. Okay. So we have to reduce the size of this number. We have to reduce the size of this number. Let's suppose I am telling you that इसको आप convert करो up to 5 decimal places में. This is the fifth decimal place that we, this is the sixth that decimal place that we have to eliminate. Okay, that is 8. That is 8. If it is greater than 5, so we have some rules. How can we round off the data? There are two cases. Case number 1, examiner has asked to write your answer up to 2 dp, up to 2 decimal places or 3. Then what you have to do, 25.378 को convert करो. Okay, 25.378 को convert करो to 4 significant figures. To 4 significant figures. अब कितना है इसके पास? 1, 2, 3, 4, 5. Right now it has 5 significant figures. We have to convert this into the 4 significant figures. So this digit is to be removed from here. This digit is to be removed from there. Okay. So then we have to see if this number is greater than 5. If this number is greater than 5 or 5. If this number is greater than 5 or 5, then add +1 to the fourth digit. Then add +1 to the fourth digit. So of course the answer would be 25.38. 25.38. So I have rounded off the number which had 5 significant figures into the number that is having 4 significant figures. Then I have to round this data into 3 significant figures. Right now it has 4 significant figures. So the fourth digit I have to eliminate. Then we have to see if this number is less than 5. So just ignore this. Then I am getting 1.360. Then I am getting 1.360. Okay, that's why like we calculate, like we do round off, okay, of any of the number. Like in some cases you will see okay, examiner has not mentioned that you have to round off the data up to 4 decimal places, up to 3 decimal places, up to 2 decimal places. In that case, what you are supposed to do, in that case, what you are supposed to do, okay, see in your calculations, in your question, how many numbers you have. Let's suppose I have these three numbers, 23.276, 3.76. Okay. Then we have to see which number is having the least number of significant figures. You will say this. इसमें सिर्फ दो significant figures हैं. Only two significant figures. Only two significant figures. Okay. तो अब क्या करें? So we have to convert the final answer into the two significant figures. That's the rule. That's the rule. Because examiner has mentioned you. Okay, you have to write down the answer in three significant figures. You have to write down the answer in four significant figures. No, he hasn't mentioned. So, so you have to think at that time. You have to think at that time to see how many numbers you are given. Okay, how many numbers you are given, and you have to see okay, which one is the smallest number, and in that number, how many significant figures we have. So let's suppose in this data, we have three numbers in which this is the smaller number having the two significant figures. So this concept would apply on, okay, each and every question. In this way, we can round off the data after after looking at the essence of a reaction. Okay, so let's see. फिर मैं वो आपको बताऊंगा. These are the few symbols for hazards. Okay, you have to take care it. Okay, first one is explosive, then oxidizing, then extremely favorable, then corrosive. Danger, danger for the environment. Then this is harmful, this is highly flammable, toxic, packed, and very toxic. These are the few hazard samples. Okay, so that's all for the instruction of paper 5. So now we are supposed to start like the paper 5 topical past papers or paper 5 yearly paper basically. Okay.